Ladies and gentlemen, today I'll be presenting on mathematics. On mathematics today, I'll be discussing one of the branch of mathematics or calculus. What type of calculus is this? This type of calculus is called differential calculus. Why differential calculus? Because it deals with the rate of change. I was told that differential calculus was introduced by Sir Isaac Newton and Godfrey Leibniz. But there were some mathematicians who made a contribution using the first principle of differentiation to solve their problems. Some of those mathematicians were Pierre de Fermat. He made contributions using the first principle of differentiation in the year 1601 to 1655. While Isaac Barron, Sir Isaac Newton teacher, made a contribution using the first principle of differentiation to solve in the year 1630 to 1677. However, ladies and gentlemen, those mathematicians introduced the first principle of differentiation to determine the maximum and the minimum functions of a curve. And they also use the first principle of differentiations to study motions and the rate of change in combination with acceleration and velocity. And they also use the first principle of differentiations to determine the tangent line of a curve at a point. Ladies and gentlemen, on this note, we'll be combining limit with differential calculus in order to solve our problem using derivatives concept. However, ladies and gentlemen, our problem is using the first principle of differentiations, given that y is equal to x squared, f of x is equal to x squared. We'll be using dy or dx equal limit. This is the short form for limit. We say limit at h approaches 0. Bracket open, f parenthesis open, x plus h equals minus f of x, bracket closes over h. On this note, ladies and gentlemen, we'll be using this mathematical formula in order to solve our problem. Before solving this problem, we say solution. On a solution, we say let f of x will be equal to x squared. And at x will just be equal to x plus h. In conclusion, we say f parenthesis open x plus h will just be equal to parenthesis open x plus h all square. So ladies and gentlemen, we'll be using these informations in order to solve all our differential calculus. On this note, we'll be taking our mathematical formula. Our formula says dy over dx just be equal to limit as h approaches 0. Bracket open, f parenthesis open x plus h equals minus f of x, bracket closes over h. Why we say dy over dx? Because we are differentiating y in respect to x. So it's dy over dx. Ladies and gentlemen, we say dy over dx will just be equal to limit as h approaches 0. What we have here, we say bracket open, we have the values for this guy, and the value for that guy is parenthesis open x plus h equals all raised to the power 2. So wherever we see this guy, we take this man and place it to represent it. So we see parenthesis open x plus h equals all square. What we have here, minus f of x. The f of x has a value. What is the value of f of x? F of x will just be equal to x squared. So we say, what we see, f of x, we put n squared. Bracket closes over h. On this note, ladies and gentlemen, we say dy over dx will just be equal to limit as h approaches 0. What happened? Bracket open. We expand this guy. In expanding the guy, we say parenthesis open, x plus h closes, another one open, x plus h, it closes. Minus, what we have the n squared. Bracket closes over h. So on this note, ladies and gentlemen, the next thing involved will be multiplying the values in the first parenthesis by the next value in the second parenthesis. So on this note, we'll bring our formula down. We say dy all over dx will just be equal to limit as h approaches 0. Bracket open. What will happen? When we multiply x times x, we have n squared. We multiply x times h, we get plus xh. Plus what we have? H times x, we get sh. Plus h times h, automatically we get plus a squared. So on this note, ladies and gentlemen, what we have here? Minus a squared. Bracket closes over h. Ladies and gentlemen, this is differential calculus. Remember, in combinations with limit, we'll be using it automatically to solve. What is limit? Limit is a value a function approaches as the input as it gets super close to a certain point. And limit was introduced by one of the mathematicians today called Augustin Lukács in the year 1821. So ladies and gentlemen, we'll be looking at this to solve our problem. We see our formula is dy over dx will just be equal to limit as h approaches 0. What happened? We call it like terms. We have n squared minus n squared. So it means the n squared minus the n squared will automatically cancel. It will be equal to 0. So we cancel, we say this and this, we cancel. So what we have here? We have xh plus xh plus h squared. So sh plus sh will give us 2xh plus what we have here? H squared. Bracket closes over h. So on this note, ladies and gentlemen, we'll be taking this guy from the bracket to solve our problem. So we say dy over dx will just be equal to limit as h approaches 0. So taking the guy from the bracket and parenthesis, we say 2xh plus a squared over h. We take this guy from the bracket because we want to factor this guy. So we'll be factoring this guy to solve our problem. Remember, Père Differential made contributions to using the first principle of differentiation to solve. And he also made a contribution to probability. On this note, ladies and gentlemen, we say dy over dx will just be equal to limit as h approaches 0. To follow this guy, we say h parenthesis open, we get 2x plus h equals over h. Why we did this? We did this because we want this and this automatically to cancel. So we'll be left with this value to solve our problem. So in our march, we bring our formula. We say dy over dx will just be equal to limit as h approaches 0. What we have? We say taking this value from here, we say 2x plus h. But remember, we already have the value for h. And when we see h will represent 0. So the value automatically for h, it will be equal to 0. So h will represent 0, and 0 will be representing h. So when I see h, I will take 0 and place 0 there, just to solve our problem. So we say the differentiation of y in respect to x, which is the y over the x, will be equal to what I have here, 2x plus the h here representing a number, all of value. What is the value for h? H is automatically equal to 0. So when we see h for 0, we say the y over the x will just be equal to, if I add 2x plus 0, I will have 2x. Ladies and gentlemen, this is our answer for today. But to prove that the differentiation of x squared is equal to 2x, we say in order to prove this, that anytime we differentiate x squared, automatically we have 2x, our answer. So we say x raised to the power 2, which is x squared. Let's prove. In proving this, we'll be looking at the coefficient and the power or the exponent. The coefficient here is 1, the power on the exponent is 2. So we'll be multiplying the power by the coefficient to get our answer. So we say 2 times 1, we get all 2x raised to the power 2. What do we do? Subtract 1 from the power. So we'll have 2x, it will take 1 from the power. When we take 1 from the power 2, automatically we get 1. So we'll have 2x raised to the power 1. And 2x raised to the power 1 is just 2x. So you see, our answer here 2x, and this automatically is the same. So ladies and gentlemen, thanks for joining me on this math journey. Keep practicing, keep pushing limits, stay curious, and let us cross those derivatives. Always remember that mathematics is the key. Don't forget to like, share, stay tuned, subscribe, and comment in the comment section. Once again, I'm Big Boy myself, Junior, popularly or commonly known as Chechi, the all-time record breaker.